we have developed and started up, which we call by trade name JetGal, has about a 65% global warming potential. So again, we are also looking at developing technologies and are developing technologies that are greener than what the competing technologies of today are. There was also a lot of talk about quality. So here, what we have done, first of all, on the left-hand side, you see the word digital twin of the coil. So in real time, we are able to determine, either by measurement or by models, the mechanical properties and the surface characteristics of the steel that is being produced, no matter whether it's during cold rolling or it's during continuous annealing or galvanizing cycles. And of course, we are making a lot of efforts to ensure that as we are producing the steel, it is meeting the specification of the customers for which it is being produced. And then online, prior to coiling, we are every meter putting barcodes which tell the customer what is the quality of that 1 meter of steel that is there. When this goes to the customer is able to read the barcode, and they can make appropriate changes in their processing line. The advantage is a win-win situation. We save by not having to scrap coils. The customer saves by not having to completely make mistakes in their stamping processes. And of course, in the future, we expect that every meter of coil that we send to the customer is going to be to the specification that he or she needs. There's a lot of talk about sorry, I'm looking at the wrong one. There's a lot of talk about automation. So what you see here, sorry, something happened, 1 second. Okay, no, sorry, okay. There's a lot of talk about digitalization. So digitalization is really a combination of a bunch of technologies, all of which are becoming more and more commonplace because of a couple of things. First of all, the cost of sensors, the cost of data storage, the cost of computing has come down significantly. Today, our concept is that digitalization is really an end-to-end concept. We have to fully integrate, fully connect everything from our supply chain, our back or up, all the way up front to the customer. This connectivity is at the core of our digitalization initiative, and also not just within one plant, but within several plants, as is appropriate. The digitalization process or digitalization is not just a matter of putting in new technology. It is really a major transformation that has to occur in the way the workforce also deals with our own operations. Therefore, this is not just a simple CapEx project where you come in and put some new tools and walk away. It's a real major transformation in the whole way of how we look and make steel. On the next slide, a couple of slides, I just have a little bit of example of that. So this is a picture of a crane that's handling a coil. The biggest problem in coil storage, of course, is the fact that you can damage the coil. So after you've spent all the money making the coil, you can damage it if you don't handle it properly. You have to scrap it. It's also a dangerous area. So both from the point of view of safety and from the point of view of quality, we have started to automate our coil storage. Now, it's not just a matter of automation, there's a lot more. There are sensors that are put on the cranes, which allow it to read what the coil is. There are algorithms that allow the whole coil yard to be managed so that the crane movements are optimized and we can recover coils at the right time for the customers. There are sensors that are put on the cranes in order to make sure that the cranes are self-evaluating their own performance. And when there are issues, they are able to then alert that repairs are necessary. So that's what I mean by saying safe, intelligent, efficient handling. So it's not just a matter of automation. And finally, I just want to point out to you that there are technologies, and the previous speaker mentioned about it, and they are not in the laboratory or they're not space age anymore. We are already bringing it to our workplace. So on the left-hand side, you have 3D printing. You have a picture, for example, of a current part, which is a welding head. By using AI and generative technologies and algorithms, we modify the shape of that particular part, taking advantage of what 3D printing can do. So you will see at the very end what the modified part looks like. Significantly simpler, and by using 3D printing, we almost have no wastage. But the whole point here is that we already are within our own company having startups which are making these kind of spare parts and providing a value proposition for us. Now on the right hand side, I have another example. I'm not sure if you can see it very clearly, but the worker has two sets of equipment on him. On the top is a shoulder harness, so to speak, and in the bottom it's more of a lower hip harness. These are exoskeletons. Maybe you've heard the word exoskeleton. We are already using exoskeletons in some of our plants, which allow, when the worker is doing heavy lifting, for example, the exoskeleton will aid the person in lifting. And therefore, the person does not have to expend as much energy and is much more a safer process. So these are the kinds of technologies I just wanted to share with you, showing what's coming into the steel industry and what's becoming commonplace. Thank you.
Thank you, Dr. Pinakin Chawal, Vice President, Group Chief Technology Officer, ArcelorMittal, for your presentation. Ladies and gentlemen, they say every once in a while, a new technology, an old problem, and a big idea turn into an innovation. To speak more on the need for innovation in the steel industry and the ideas whose time has actually come to mentally stir you all, we have this session on Innovation Pitch. Our next speaker in this session is Dr. Indraneel Manna, Professor, IIT Kharagpur, and I request him to take the dais.
So, good afternoon, colleagues seated on the dais and colleagues in the auditorium. See, when I actually received an invitation from Monica Bachchan, made me very happy for two reasons. Number one, I never imagined in my wildest dream that any Bachchan would ever call me on the phone. I was also happy because the topic was about innovation in steel. I'm a metallurgist, and I know for sure that this is an area which is not only close to my heart, is absolutely and very eagerly awaited in this country, which no matter what we tend to profess, it continues to be a developing nation. Steel, everyone would agree, is the second largest tonnage-wise material used and is always considered as one of the developmental index in a developing nation like India. Now, when I arrived in this venue, I immediately could make out that I'll be kind of an odd man out here because the entire forum is very heavily dominated by cheers from the industry. So coming from academia, obviously what you're going to listen from me is going to be a little different. And so be it, then it's actually at times better to be an odd man out because then people are willing to listen to you. So in a country of blind man, you always can take the liberty of defining the same thing which all others would have also seen, the same elephant. So here is my take on what I believe is actually the scope of innovation. In order to do that, I'll step back and start with my own jargon for defining what is science. In my opinion, science is simply know why. We all know that if you try to deform ferrite, it deforms very easily. When you try to deform cementite, it doesn't. So if you ask the fundamental question as to why one deforms and the other one doesn't, you're asking essentially the scientific question. No one knows whether actually an apple fell on Newton's head, but everybody would agree that he was the first to raise the fundamental question as to why would an apple always fall and not fly up. And the result was the fundamental laws called laws of gravity, which we all know how useful that is. The same way when Michael Faraday first showed that if you apply potential difference, electrons flow along the conductor, constitutes electric current. He didn't realize that someday in future, every place will be illuminated by electrical or incandescent bulbs. It took the genius of Edison to come forward and show how you translate know why into know how. And that's engineering. So if science gives you occasional discoveries, engineering gives you inventions and demonstration of the utility of the scientific know-how. But it's actually the last mile which always matters to the society, which is know what sells. And that's where the industry comes in. Industry is the biggest custodian of the innovation. And today's turf is laid out for innovation, so I thought I would spell out my own understanding of this interrelationship. And if you look at this definition, what I call a perpetual triad, at the centroid you have something called society. And it is because of the society they all are interconnected. The same person can be a scientist, an engineer, even an entrepreneur or an industrialist. The same organization can do all the three activities. And they are not disparate objects, they are all interrelated. So if we talk of innovation, and that too for innovation in steel, we must realize that the beginning has to be made from science, has to be demonstrated and upscaled to a level whereby it can be replicated in numbers and eventually